tires, each cord is drawn from its individual spool. Guided by thousands of tiny eyelets, the cords are carried to a specially conditioned room where the temperature and moisture are strictly maintained to preserve full strength and elasticity of the cords. The manufacture and processing of the insulated cord construction is far more costly than the processing of ordinary pick fabric. Here, each cord must be held in positive position until it passes through huge calendars and formed into a wide sheet of ply stock containing 1,800 cords, thoroughly and evenly coated with a special rubber compound. The rubber used for this ply stock is so compounded that it possesses high anti-friction properties, which give further protection against internal friction and wear. The angle of the cords in the ply stock is an important factor in the life of the tire, because a definite angle is necessary to give proper balance to the body plies. In order to assure the correct angle and exact width of the plies, this enormous cutting machine is used. Accurate to a fraction of an inch, the strips are carried to the tire room individually on an immense system of conveyors. Another important part of a tire is the bead. The wire used has a breaking strength of 280,000 pounds per square inch. Each strand is thoroughly insulated with a special rubber compound, then automatically formed into a circular band. The spliced ends are taped, and on another machine are covered with a special rubberized fabric. This fabric covering is called the flipper. It's used to anchor the body of the tire. Another long, safe mileage feature of Brunswick tires is its famous safe and efficient tread. In order to produce this tough, wear-resisting tread stock, 7 different ingredients are blended in with the highest grade of raw rubber obtainable. Each ingredient is accurately weighed before it is mixed in the huge Banbury mixing machines. These machines mix 800 pounds at a time, and then dump the batch to a conveyor belt which carries it to a series of large cylindrical rolls called mills for further mixing with additional compounds. These mills not only mix the rubber, but knead it as well, much as bread dough is kneaded before baking. Another mill heats and prepares the stock, cutting it into a large, thick, continuous ribbon before it is fed into a machine which forms it into proper shape in width and thickness. Here it begins to look something like a tire tread as it travels along a 300-foot conveyor to be cooled, weighed, and checked. A special compound of adhesion gum is next applied and thoroughly rolled onto the underside of the raw tread strip. This layer later becomes a part of the double shock absorber unit, which provides the positive adhesion between the tread and the carcass. At the end of this long conveyor is an automatic cutting machine, which measures out and cuts the tread stock into the exact length required for different sized tires. Further check, however, is made on the weight of each strip of tread stock to assure proper balance to the tire. If the weight is off a fraction of an ounce, the strip is rejected. In the tire building room, the components are assembled. Plies, beads, flippers, tread stock, finishing strips, and double shock absorber units made ready for tire builders. Skillful operators with years of training and with equipment of the most modern type. This cylindrically shaped machine is called a drum. Each ply is rolled accurately and smoothly into place, one ply at a time. A system of rollers shape the plies to the drum and press out all air pockets between the plies in order to produce positive union of all parts of each ply. After the second ply is rolled down, the beads are placed on each side. The flipper strips surrounding the beads are securely fastened to the edges of this second ply, and the edges of the body fabric are lapped over the beads, locking them firmly into the body of the tire. The additional pliers of cord fabric are then added one by one until the carcass is completely built up and prepared for the tread stock. One of the most common causes of premature tire failures and blowouts is the separation of the carcass and the tread. In order to eliminate this hazard, Brunswick has developed the double shock absorber unit. That's the center unit being applied. It consists of 2 extra layers of cord material treated and coated with a special cushion compound, which not only ensures positive adhesion of carcass and tread, the body also protects from high-speed road shocks by absorbing and distributing them over a wide area of carcass. Double shock absorber is an exclusive Brunswick feature and found only in Brunswick Super Service tires. The 2 black strips at the sides are chafing strips. They protect the lower sidewalls of the tire from rim chafing and keep the flexing action of the sidewalls evenly distributed above the point of rim contact. The thick, tough tread stock is next placed smoothly and evenly over the entire carcass, the ends spliced securely together. It is rolled firmly and pressed to the carcass by the rollers at the bottom of the drum. When it's removed from the building drum, it's in the form of a hollow cylinder. It doesn't actually look like a tire until it's shaped in the forming box. Now here the tire is prepared for the mold. A heavy rubber tube called a water bag is placed inside the assembled tire in the forming box. A quick application of heat, and the tire is shaped to fit the curing molds. In the curing of a tire, heat and pressure should be applied uniformly to the inside as well as the outside of the tire. Otherwise, the rubber coating of the inner plies would be of a different consistency than the rubber. In the finishing room, they're sprayed with tire paint, trademarked, striped, and balanced, then put through a rigid inspection test. In spite of the thoroughness, the constant check during each phase of manufacture, every tire is thoroughly inspected inside and out. No blemish or imperfection is overlooked. Every tire must check with the exacting specification set for it. Specification set by one of the most outstanding groups of research engineers and chemists in the industry. In the research laboratory, there's a constant quest for the better than best. Day after day, the search for new developments and product innovations is diligently carried on. Anticipating the needs of tomorrow, new formulas, new compounds are developed in a miniature factory. Toy-like in comparison to the huge equipment of the plant, but exact in detail are the Banbury mixing machines, mills, calendars, and vulcanizers. Here, small experimental batches of rubber are carefully compounded, mixed in miniature mills, rolled into sheets on small calendars, and cured in tiny ovens. Samples of these cured sheets of rubber compound are tested for their strength, stretch, elasticity, and resistance to wear. Every new compound is also tested for flexibility and its resistance to heat, set up by friction. Ply stock is experimented with and studied just as thoroughly. Each component part receives its share of attention. Samples of cord are weighed and flexed on specially constructed devices both before and after they're conditioned in experimental ovens. Stretch and breaking points of cords are constantly being checked and charted on tensile strength machines. This laboratory checks not only experimental materials, but samples of all raw materials used in production as well. Sections of carcass and tread welded together or vulcanized by various experimental methods and compounds are flexed and tormented by specially designed flexing machines to determine their adhesive properties. Other tensile strength machines are used for a pull test to measure the number of pounds necessary to tear the tread from the carcass. This test proves the positive adhesion attained in Brunswick Super Service tires by the double shock absorber unit, not only on a cold pull test, but on heat tests as well. There's a section of the laboratory known as the torture chamber. It's aptly named, because a tire that will run this gauntlet of tire-destructing mechanisms and survive truly earns its right to be called one of the finest tires ever built. Here is a Brunswick Super Service inflated to a pressure 4, 5, 6 times its regular inflation point. Pressure is forced into it until it bursts. The men conducting these tests are protected by heavily insulated partitions. Pound by pound, water is forced into the tube under pressure, inflating the tire to 200 pounds or more until something must give. Under this terrific pressure, the steel bead snapped, but the tire itself did not blow out. Another device is used to test the possible injury to a tire as a result of hitting into curbs or road obstructions. A tire is mounted on a heavily weighted steel rim and dropped on an iron cleat.
Take a bale of natural rubber, for instance. First thing you know, sort a giant meat grinder chews the rubber, softens it, gets it ready for processing. Different rubber products have different recipes, but they all start out the same way. Got to be mixed. One way is to put the rubber and the chemical compounds into a Banbury mixer. Or you squeeze the ingredients in a rubber mill till the rubber's smooth, even. I saw my first barrel tire. Tires are built up layer by layer using sheets of prepared rubber with cords inside. Cords come from textile mills. That's how rubber companies got into the textile business. There's a tremendous amount of work to be done before they start putting the actual tire together. They have to coat the cords with latex. Then they squeeze a coating of rubber over the cords. Then they put the barrel tire into a machine that shapes it and vulcanizes it, all in one operation. Most rubber goods have to be vulcanized to give them their permanent shape. There she was, looking like a donut, or a tire.
Tires, each cord is drawn from its individual spool. Guided by thousands of tiny eyelets, the cords are carried to a specially conditioned room where the temperature and moisture are strictly maintained to preserve full strength and elasticity of the cords. The manufacture and processing of the insulated cord construction is far more costly than the processing of ordinary pick fabric. Here, each cord must be held in positive position until it passes through huge calendars and formed into a wide sheet of ply stock containing 1,800 cords, thoroughly and evenly coated with a special rubber compound. The rubber used for this ply stock is so compounded that it possesses high anti-friction properties, which give further protection against internal friction and wear. The angle of the cords in the ply stock is an important factor in the life of a tire, because a definite angle is necessary to give proper balance to the body plies. In order to assure the correct angle and exact width of the plies, this enormous cutting machine is used. Accurate to a fraction of an inch, the strips are carried to the tire room individually on an immense system of conveyors. Another important part of a tire is the bead. The wire used has a breaking strength of 280,000 pounds per square inch. Each strand is thoroughly insulated with a special rubber compound, then automatically formed into a circular band. The spliced end